So in this example problem, we're going to find the centroid of the wire that's shown in the picture below. This would be a problem where you'd find the centroid of a line composite section. So the first step in order for us to determine the centroid, so we're looking for x bar, y bar, and z bar in this situation, is we need to first break the composite body, or our composite body, into sections. Alright. So looking at this composite body, I see we have a curved section that lies in the XY plane. We have a straight section that's 40 millimeters in length that lies along the y-axis. And then we have an additional section of 20 millimeters that goes along the negative z-axis. So I'm going to label those three sections. Section 1 is the curved section. The section that goes along the y-axis I'll call section 2, and the one that goes along the z-axis that's offset a little bit is going to be section 3. Right? So once we break our composite into 3 sections, what we're going to do next is we're going to determine for each section we need to determine what is the section's centroid. Alright, so those are our x tilde, y tilde, and z tilde. So for section 1 here, alright, we have x tilde, since it's it's an arc, a semicircle arc that has a radius of 60 millimeters. X tilde would occur along the line of symmetry along the along the y-axis. So this distance here would be equal to 60 millimeters. So we can say that x bar would be equal to 60 millimeters. All right. Y tilde for this section, it's a little bit more difficult to calculate or to view by inspection. So in order to calculate what y tilde would be equal to, we need to go back to our table. So if we go back and look at our table here, we have the centroid location for a semicircular arc is given to us by this equation here. This equation here. So the location C is going to be equal to 2r over pi. So we go back. Our radius is equal to 60 millimeters, so 2r would be equal to 120 millimeters over pi. Alright, so this is just equal to 2r. Alright, so then the last thing we need to know is we need to know what the heck is z tilde. Since the section 1 lies within the xy plane, z tilde would be equal to just 0 millimeters. Alright, and then the last thing that you'd want to determine for each section is you'd also want to determine the length. So the length of section 1 is just going to be is also given in that table. So the length of a semicircle is just pi over r. Right. So in this case it would just be equal to pi times 60 millimeters. Alright, which makes sense. Alright. Alright. So section 2, alright, is just goes from the origin to 40 millimeters along the y-axis. So x tilde would be equal to 0. There's no part of it that has any x component at all. Y tilde would be equal to half of the length which in this case would be equal to 40 millimeters divided by 2, or 20 millimeters. Alright, and then the z tilde would be equal to 0. There's no component in the z. And then the length of section 2 is just given to us as 40 millimeters. Alright, and then the last one would be for section 3. Alright, so section 3, x tilde would still be 0. There's no component along the z, along the x-axis. Y tilde, since the entire section is at a offset of 40 millimeters, y tilde would also be equal to 40 millimeters. And then z tilde would be equal to half of the length, or I should say minus half of the length. So the length is equal to 20 millimeters, so it would be equal to negative 20 millimeters divided by 2, or minus 10 millimeters. Right? And then the length of the section of section 3 is equal to 20 millimeters. Alright. So once we have x tilde, y tilde, z tilde, and the length of each section, what we're going to do now is we're just going to tabulate all this information that we just got. So we're going to have our first column of our table will be, so this is going to be our tabulation, and then after we tabulate, we're going to calculate. Alright, that's our third step. Alright. So we're going to have section body, or our section number, will be our first column. Our second column is going to be equal to x tilde. That'll be in millimeters. Our next column would be equal to y tilde. That's going to be in millimeters. Then the next one would be z tilde. That will also be in millimeters. Alright, and then we're going to have the length in millimeters will be our final column. Alright, and then we're going to have, alright, so I'm going to pause the video for a second just to write all those numbers down. Alright, so now the numbers have been copied down. The last thing we need to do is we need to determine for each of our bodies, we need to determine what is the value of x times the length, x tilde times the length, y tilde times the length, and z tilde times the length. Alright, so the first one we're going to have is equal to 60 millimeters times 60 pi, so that would be equal to 3600 pi. Y tilde times the length would be equal to 60 pi times 120 divided by pi, so the pi's would cancel out. We'd be left with 7200. And then the next one we would get would be z times the length, which would just be equal to 0. And then for the second body, we would multiply x tilde times L. That would be equal to 0. Y tilde times L would be equal to 800. And then the one thing I forgot to include, for y tilde, there should be a negative sign here, because it's going along. For section 1, it should be a negative. There should be a negative sign there. So y tilde times the length should be equal to minus 7200. And then z tilde times the length for body 2 should be equal to 0. Alright, and then for the body number 3, we should get would just be equal to 0 for x tilde times L. For y tilde times L, we would get 800. Alright, and then z tilde times L we would get minus 200. Alright, so to calculate our x bar, our y bar, and our z bar for the wire, we need to apply the three equations for the centroid. So for x bar, we know that it's equal to the sum of all the x tildes times the length divided by the sum of all the lengths. The wide bar is equal to the sum of all the products of y tilde times the length of each segment divided by the sum of all the lengths. And then z tilde we know is equal to the sum of all the z tildes times their lengths of each section divided by the sum of all the lengths, or the total length. So to determine these 1, 2, 3, and then 4 quantities, we can just sum the columns of our table that correspond to each of those. So we're just going to sum up these 4 columns on the right hand side of our table. Alright, so for our total length we would get 60 plus 60 pi millimeters. XL would be equal to the sum of all of our XLs would be equal to 3600 pi. The sum of all of our Y tilde L's would be equal to negative 5600. And then the sum of all of our Z tilde L's would be just equal to minus 200. Alright, so just to reiterate this is our sum of all of our lengths is for the left column. For the second column, we have the sum of all of our X tilde L's. For the next to last column, we have Y tilde, the sum of all our Y tilde times L's. And then for the last column, we have the sum of all of our Z tilde times L's. Alright, so if we plug in all those values into the equations we have written on the right, we would end up getting x tilde would be, or x bar would be equal to 45.5 millimeters, or y bar would be equal to minus 22.5 millimeters, and then our z bar would be equal to minus 0.805 millimeters. Right. So there's nothing wrong with doing this by hand, but you can definitely do this. If you're asked to do this in the future, you should definitely check your work at least, at minimum, using Microsoft Excel. It'll make your calculations go a lot quicker, right? So, alright. So to recap, first thing, you need to break your composite body into sections. So we broke our composite body into the 3 sections: section 1, section 2, section 3. Once we did that, we determined x tilde, y tilde, z tilde, and the length for our 3 sections. We then took that information, we wrote it into this table here, and then we calculated the products: x tilde times the length, y tilde times the length, and z tilde times the length for sections 1, 2, and 3. We summed up those numbers for to determine the total length of the system: the x tilde times the length, the y tilde times the length, the z tilde times the length. And using the 3 equations for the centroid of for a line, we calculated our x bar, y bar, and z bar for the total system. All right, and you can check your values using Excel. All right, that concludes this problem on finding the centroid of a line.